Hello students, welcome all of you. Now we shall see the fourth program in your SSOS lab, where the fourth program again is based on parsing technique similar to the third program, but it is more based on the bottom-up parsing, whereas LL1 parsing that we discussed in the third program was completely based on top-down parsing, but here we shall see a type of bottom-up parsing which is a shift-reduce parser. Now, according to the shift reduce parser, it works in a way such that it works as that is it's a bottom up parsing. But when you take any RMD, that is if you take the rightmost derivation of any grammar, the parsing technique processes as the reverse of RMD. Meaning whatever the RMD symbols, how the RMD steps progresses, that is how the rightmost derivation steps progresses. The program or the contents of this parsing works in such a way that it is the reverse of RMD. As it is the bottom of parsing, it has to progress as reverse of RMD. Now the grammar, if you see the output, if you see this particular output, the grammar is E derives E plus T or T derives T star F or F derives E or ID. Now the string to be passed is ID plus ID star ID, where the shift reduce parser or the bottom up parsing involves two methods, that is the shift and reduce. There are two actions here, two prominent actions. Actually, there are four, that is the shift, reduce, accept and error. Now, if the input symbols are completely reduced to your given grammar, that is towards the reverse of RMD, then the grammar obviously would be accepted, the string would be passed, and you reach the accept state. Otherwise, it is an error state. But prominently, there are two actions, that is shift and reduce. Now, whenever the input symbols are to be passed or are to be processed, you shift the necessary symbols onto the top of the stack. Now, if you want to process it as a reverse of RMD, you reduce or you perform the reduction operation. Now, if you look into the stack, if you look into this particular stack, yeah, a parsing table is being shown here, that is which has a specific headings, that is a stack, input and action. Stack, input and action, they are the specific headings that are being shown here. Now, initially the string is ID plus ID star ID. So my default action, by default always, the shift reduce parser always has the default action as shift. So you shift the input symbols onto the top of the stack. Now, as you progress towards the reverse of the RMD, as you progress towards the reverse of RMD, that is rightmost derivation, we shall see the following symbols. That is id can be reduced to f using the grammar as that is f derives id. So instead of id you can replace it with f. Next again I can reduce f to t using the grammar t derives f. Using the grammar t derives f, I can arrive at I can replace f with t here. Now the input symbols I haven't touched. Now again I can replace t with e, that is as E derives T, I can replace T with E. I will still touch the input symbols here. Then I shall shift plus now. Now this becomes E plus ID, star ID that remains common. Now again I shall uh, shift ID here. That is I'm performing after plus, I'm shifting ID here. Again ID is replaced to F, again F is replaced to T. So again I need to arrive at the start symbol, meaning the start symbol is E. So start symbol can be arrived using the grammar E derives E plus T or T. So my best option is to arrive at the final grammar as E derives E plus T. So I shall, there are still more further symbols left in the input string. So shift all of them. That is the star followed by ID. So you will have only the dollar, that is the end symbol in the input string. Now T star F, I can reduce it to T using the grammar T derives T star F. Now E plus T I can always reduce it to E because E derives E plus T. So this is working as the reverse manner of the rightmost derivation. So how you progress through the rightmost derivation, in the same manner the program is being written. The program is being written in the same manner. If you observe the program, how many steps you have, those many number of functions you have in the given specific program. those many number of functions you have defined in a specific, in your given specific program. So we shall see that. So how many number of reduce and how many number of shift operations there, each one it's being written. So shift one, so how the parsing table progresses. After shift, there is first reduce, then the second reduce, then the third reduce, then again there is shift. So how the parse table progresses, the shift and reduce operations progresses. So again, the replacement is normal string operations that is being replaced. Normal string manipulation functions are used to replace. Finally, it is the accept. So finally, if you reach the start symbol of the grammar, that is E in this case. So if you reach the start symbol of your specific grammar, you accept. Otherwise, you declare it as an error. I hope this part, the execution is understood. Now, as it's a normal C program, as it is a very basic normal C program, there is only string manipulation functions that's being used. So if you want to execute this in Unix platform, again use the editor gedit. Using the editor gedit followed by the file name, that is the extension should be .c here. Now once this is done, you can compile the program using cc. Now the output of this program is a.out. You execute this using /a.out. There is no input to this as you are completely arriving at the parse table here. So the complete arrival of the parse table is being shown. I hope this is understood by all of you students. Uh, please try to understand the execution steps. And the code is really simple according to the parse table. It is written according to the parse table.